We are live. Hi everyone, welcome back to Code Era. Today in this video we'll be discussing the LeetCode daily challenge for today, that is 27th of January. The name of the problem is maximum XOR of two numbers in an array. This is a very popular interview problem. Previously this problem has been asked in organizations like you can say Amazon, Adobe and Google. It might have been asked in a lot of other companies as well, but more frequently it has been asked in Google, Microsoft, Amazon and Adobe, right? So quickly give me a +1 in the chat if my voice is audible to everyone and my screen is also visible, and then I'll start with the problem, right? So in this particular problem, what you'll be given is you'll be given an array of integers, that is nums, and you have to return the maximum result of nums XOR nums of I XOR nums of j, right? So you have to find two elements in this particular array such that their XOR is maximum possible, right? I hope that this much problem statement must be clear to everybody. Now I'll be explaining you a few things before beginning with the question, right? So just give me a second. So starting with the problem. This problem, as I told you, it has been asked in companies like previously it has been asked in companies like Google. It has also been asked in Amazon and Adobe, right? So what you have to do is you will be given an array, right? You will be given an array, and what you have to do is you have to find two elements such that XOR of those two elements, XOR of any two elements of this particular given array is maximum possible, right? Is this much problem statement clear to everyone? Please let me know in the chat. Is this much problem statement clear to everyone? You have to find the XOR of two elements, of two array elements. The array is an integer one. It is consisting of some integers. You have to find the XOR of two elements such that their XOR is maximum possible, right? So what does a XOR mean, right? What does a XOR mean? So if I am talking about the XOR operator, so if a bit is 0, if the bit is 0 and I XOR it with 1, so it becomes 1, right? Okay, n square gives time limit exceeded. Yes, it will give a time limit exceeded, right, Lalit? We'll be talking about that as well. So if I have 1, if I do 1 XOR 0, what do I get? I get 1, right? If I do 0 XOR 0, then I get 0. If I do 1 XOR 1, so I get 1. So whenever there is a bit, so if I do its XOR with the same bit, right? If I do 0 XOR 0, so I'll get 0. If I do 1 XOR 1, so I'll get 0, right? Otherwise, if the bits are different, either this is the combination or this is the combination, then in that case I would be getting 1, right? Is this much part clear to everyone? I hope that this much basic operation of XOR is clear, right? Now the thing is that you have been given some elements, right? You have been given some elements. Let me say what are the elements that have been given. Like let's say if you have an element a of I and if you have an element a of j, so whatever you will be doing, this you will be applying this XOR operator here, right? You will be applying this XOR operator here, and then you will be getting the XOR value for that particular thing, right? So this is what does the XOR mean, right? Now let me take some test cases from this particular problem. So let's say the test case is 3, 10, 5, 25, 2 and 8, right? If the test case is 3, 10, 5, 25 and 8, like this, if this is the test case that is given to us, right? So in that particular case, what would happen? In this particular case, if you have to find an I and j, if you have to find a pair of ai and aj, right, such that ai XOR aj is maximum possible, right? Is maximum. In that case, what you could do is you can, let's say you start your I from here, and then you can start your j from here, and you can like first of all see what is 3 XOR 10, then you can see what is 3 XOR 5, then you can check what is 5 XOR 25, then you can check what is 3 XOR 8, like this. Okay, after that you can maybe start your I from here and you can see what is 10 XOR 5, what is 10 XOR 25, what is 10 XOR 8, like this. Okay, so for every element you can check with every other pair, right? For each element you can check it with every other pair. So in this case you will try for a nested loop, right? Nested loop. What will you do? You will say that okay, if we are trying for a nested loop, in that case what would happen? I starts from 0, I is lesser than n, and I will be doing an I plus plus, right? And for j starts from what? I plus 1, right? This is what I would be doing. J is lesser than n, and then j plus plus, right? So what I will be doing is, let's say the current XOR is x is equal to nothing but a of I, XOR a of j, right? Like this. And then what I would be having is, I would be having a maximum which will be initialized to int underscore min, right? Int underscore min. And what I would be doing is, I would be checking mx is equal to nothing but maximum of mx comma the XOR that I am getting currently, like this. And in that case I can do it. This loop is running order of n time, right? This loop is also running order of n time. So the overall time complexity, as Lalit also stated, would be order of n square. Now this would give you a TLE if the n value is something like 10 to the power 5 or 10 to the power 6, something like this, right? So how can we do something better than this, right? That's the question. Now there are two approaches to this problem. They could be like, you just, first of all, the thing is clear that you have to deal with the bits. You have to deal with the bits. Now if you want to see this, so if you have a bit 0, then if you XOR it with 0, then you will get 0. Similarly, if you have a bit 1, if you XOR it with 1, then you will get what? You will get 0, right? So if you XOR the same bits together, in that case you will get 0. If you XOR different bits, so if you XOR 0 with 1, then you get 1. If you XOR 1 with 0, so you get 1, right? So these are the situations that you would like to have. Now the thing is that how do we do this, right? So there is a data structure that we have, that is trie data structure, right? So I'll be telling you about this trie data structure and how we'll be implementing with this data structure. So what I would be doing is, like, I would be building a trie data structure first of all, right? I would be building a basic trie data structure. Let me first of all write all the elements that I have. I have the elements 3, 10, 5, 25, 2 and 8, right? I have 3, 10, 5, 25, 2 and 8. These are the elements that I am having. What I can do is, I can build a trie with this, right? I'll say that, okay, this is the first node. Then I'll say that I have to represent, like, this is the head of the trie, and what I will try to do is, I will try to represent all these numbers with the help of a trie, right? I will try to represent all these numbers in a trie. How will I do that? I'll let you know. If I say what is the representation of 3, can I say that the representation of 3 is nothing but 101 in terms of binary? So if I have to represent 3, so that means that I have to go towards the, also if in a trie I am building a trie, so what I am assuming is that if I am at the current node, right, if I am at the current node, so this is the head of the trie, right? If I am moving towards the left, so that in that case the bit would be 0. If the bit is 1, then in that case I would move towards the right, and I will put a node, I'll add a node 1 towards the right. Okay, is this much part clear to everybody? Is it clear to everyone, right? Okay, this is what I would be doing. Now let's see what we'll be doing. This is the head of the trie. Okay, now let's try to build this particular trie. What I would be doing is, first of all, I'll see what is this bit, right? The bit of 3 is 1. So I'll say that, okay, I need to move towards the right of the trie. I'll be telling you how we'll be writing the code for this as well. Just consider giving a +1 in the chat if up till now things are clear to all of you, right? Consider giving a quick +1 in the chat if up till now things are very much clear to all of you, right? So what I would be doing is, if I am going towards the right, so I'll mark it as 1. Now from this particular current node, I have a 0, so I'll go towards the left. So I'll go towards the left, this would become 0. After that I have 1 here, so I'll go towards the right and I'll have 1 here, right? Like this, something like this. Okay, this is how I would build it. Now I'll see what's the next number. So the next number is 10. Now I'll see what's the representation of 10. So if I look at 10, so how do I represent a 10, right? So if I have to represent a 10, I think it looks like this. That is 1, 2, 4 and 8, like this. Okay, so the representation of 10 is like this. Okay, this is the representation of 10. So that means the first bit is 1. First bit is 1. So I'll say that, okay, first bit is 1. So this means I can go to this part, that is first bit is 1. Then I will say that, okay, the next bit is 0. So I'll say, okay, the next bit is 0. So this is the path. Then the next bit is 1. So I'll say, okay, this is the next bit as 1. Then I have one more bit which is 0. So I'll say, okay, this is the next bit which is 0, right? Like this. Like this. Okay, this much must be clear. If you iterate till here, so this will give you 101 and it would be the representation of 3. If you iterate from here till here, that is 101010, so it would give you what? It would give you the representation of 10, right? Like this. Correct, you can correct me if you think I am wrong, right? This is how it would look, right? Now I'll have the next number. I'll see what is the next number. So I can see that next number is nothing but I think I've made the representation for 5. 5 is nothing but 101, I guess, right? 1, 2 and 4. Sorry for that. Like, I have done this mistake. So I have initially represented 5 and 10, right? So now I'll be representing 3. So if I have to represent 3, How does it look? 3 looks nothing but 1 and 1, right? So what I would be doing is 3 looks 1 and 1. So first of all, I am at the head. So from this, if there is 1, so I'll go towards the right. And then what I will do is I'll go towards the right again because I have to build 3. So this is 1. So now what will happen? This part is nothing but the representation of 3. This part 101 is the representation of 5, right? And this complete part like 1010 is the representation of nothing but 10, right? This is what I'm doing. I'll be telling you how we'll be using this try to our advantage as well. But let's first of all build this try, right? So this much building is complete. Now I'll be building for 25. Let's say I'm building for 25. So how do I represent at 25, right? How do I represent at 25? So if I have to represent at 25, the last bit would be 1. Then let's say it looks like what? 1, 2, 4, 8. I'm trying to build it, okay? 1, 2, 4, 8, and then 16, right? And then this would be what? 32, something like this. So it means that this particular bit and this particular bit should be set. So that means 16 plus 8 would be give me what? 16 plus 8 would give me nothing but 24, right? 24 plus 1, 25. So this is the representation like 1, 1, 0, 0, and 1. This is 1, this is 2, this is 4, this is 8, and this is 16. So 16 plus 8 would give me what? 16 plus 8 would give me 24. 24 plus 1 will give me 25, right? So I have the representation of 25. What's the representation of 25? The 25 representation is 1, 1, 0, 0, and 1. So let's see how we'll do this. So it is 1, 1. So I say okay, 1, it is 1, 1. Okay. So I'll say okay, 1. I come to 1. I come to 1 again, right? I have this representation 1, 1, 0, 0, 1. So I have 1, right? 1. Then I come to 1. Then I have the 0. So I have to build a 0 here. I have to build a 0 here like this. Let me write it a little bit more clearly. Right, I have to build a 0 like this. Then I have another 0. So towards this side, I have to build another 0 for this. And then I have a 1. So I'll build a 1 for this here, right? This is how I'll do it. Ashish, is there any way this can be solved without using try? Yes, Ashish, this problem can be done using the concept of map, using the map concept as well. But that part won't be much intuitive. It will take much more time. Like it can be done using a map or a set or something like that. But in that case, it would take order of 32 into n. In our try solution, it would take order of n into log of the maximum number, right? So I'll be explaining you try. If you haven't learned tries, then in that case, Hashish, today you will learn try. So don't fear about this, like, right? You are seeing that how we are building this particular try, right? So if I have 25, so I'll build it like this. Now the next step, I'll see what's the next number. The next number is 2. So I'll see what's the representation that I have for 2. So for 2, I can safely say that for 2, the representation is what? For 2, I'll have 1, 0, right? That is 1 and 2, right? Like this. So 2's representation is this. So I can see that 2 is already built here, right? 2 is already built here. That is 1 and 0, right? So I'll say, okay. That is, first of all, I had moved to 1, then I moved to 0. So I know that, okay, 2 is built. So I'll say, okay, 2 is also built. Now I'll see what's the next number. The next number is 8. If I have an 8, so that means I have 0, 0, 0, and 1, like this. I have this number. So I'll need to check whether this number exists or not, right? So like 1, 2, 4, 8. This is the representation of 8 in our particular manner, right? Please give me a +1 in the chat if up till now things are getting clear, right? So this is the representation of 8. Now notice that how I am trying to do this. So if I have a 1, so first of all I'll go towards the left. I have a 1, then I have a 0, so that's perfect. So I have, up till now I have completed, but now I have another 0, but here I do not have a 0. So I'll add a 0 at this part, right? After that I have another 0, so I do not have any 0 currently, so I'll add a 0 to this, right? So in this way I have represented all the numbers. Now the data is not very much varied, otherwise this tree could have been a lot of expanded, right? If we had more data, then this try could have been look like this. Like it could have had a lot of branches like this, okay? So it could have had a lot of branches, but that depends on the data. Our data was not so much different, so that's why most of the numbers got built in, but that's okay, that's perfectly fine. Now what I'll do is this is the try that we have built, right? Please give us a +1 in the chat if you are satisfied with the try that we have built, right? We have tried to build the try with what? We have tried to build the try with nothing but the basics, right? With the basics, that is with the representations, right? So we had 3, we had 5, we had 2, we had 25, we had 8. Think numbers like these. Let me check. So 3, 5, 10, 25, 2 and 8, right? 3, 5, 10, 25, 2 and 8, right? These are the numbers that we had. Perfect. Now these are the numbers that we have. Now what would we do with these numbers, right? So now let's check for these numbers again. Let's bring these numbers into context back again. So now once I have 3, so what is the representation of 3? 3's representation is 101. The way I represent 3 is 101, right? I can represent 3 as 101. Now if I want to maximize my answer, then in that case, in place of this bit, I need a 0. Can I say this? In place of the bit where 3 is having a bit 1, I need a 0, right? I can say this, that in place of this, I need a 0. Right, if it's present, right? To maximize it, I need to do it with opposite bit. If this is bit is 1, then I would try to search I will try to go in the try with that path. I understood your explanation but not satisfied with try. Okay, no problem, you will understand it better. Let me iterate through it, man, once, right? So what I'm saying is 3 is looking like this. 3 is looking like 1, 0 and 1. So let's try and see what 3 is making. 3 is making 101. If I have to make the maximum, so I have to XOR it with a number like this, then it would be 111. So now that depends on the try whether I have all the data like that or not, right? So if I have 1, so I'll try to see is there a 0 existing. So I can see that from the head there is not a 0 existing. So I'll say that no, I'll have a 1 only here, right? I'll have a 1. I do not have any option. So I'll have to move in this direction for this. So I'll have a 1. Now the next thing is I have a 0 here, right? I have a 0 here. So I have a 1 here. Now I have a 0 here, right? I have a 0 here. So do I have a 1 for this? So I'll say yes, I can go for a 1 here, right? So I'll say that okay, I can have a 1 here. I did not have a 0 for this particular one, the most 8-bit one, but for this particular 0 I have a 1, because from this one I can go to this one, right? So that's why I'll say that okay, I can make it. So what I'll do is I'll say that okay, this is the number, like what will happen I'll tell you, right? So this is the number 1, right? So I'll say that okay, I've made it. Now I have a 1. Can I, from this one, can I go to a 0? Yes, I can go to a 0, right? From this one I can go to a 0, because what is happening, this is 1. I want to find that whether the next bit can be 0 or not. I can see that in the try I have a bit 0. From this current 1 I can go to 0, right? So that's why I can go to a 0. So that's why what will happen, this I will XOR it, right? These are the values. Now I'll XOR it. So let me see what I'll get. I'll get 0. I'll get 1 and 1. So what I'm getting, like this was not the number 3, sorry again, like I have represented 3 in the wrongest way possible, right? Sorry for that. 3 was not that number, sorry, right? You are very speedy. Take pause. Okay, I'll take some pause. Okay, I'll try to take some pause. Okay, right? So if I have 3, so I have the representation is 1 and 1. So what I will check is for this particular bit, if this is 1, if I want to XOR it, so I'll try to search whether there is a 0 in the try or not. So initially from the head there is no 0. So that is why I'll say, since I do not have any 0, so I have to move in the direction of 1. Now if this is 1, so I have to check whether I have a 0 or not. So can I go to a 0 from this one? Yes, I can go to the 0, right? Its left is existing. So since its left is existing, so that means that I can go to a 0. So that is why I'll go to a 0. I'll go to a 0 and I'll say that this is the number that I've XORed it with. So if I XOR these two numbers, so what do I get? I get 0 and 1. Right, so this is the binary representation. So this, if you represent this, so this number would be 1, right? So I'll say that okay, up till now the maximum number that I have got using XOR is maximum is nothing but 1, right? I'll say this and I'll say that okay, let's check for the next number. Now once we'll be checking for the next numbers, so you'll be much more satisfied with what we are actually getting, right? Just be a little bit patient with me, right? If you have 101, with this bit you will want that can you go to the left or 0, right? From the head you cannot go to the left because you do not have the 0, so you have to compromise with the 1. So you put a 1 here, but you had to try to put a 0, but you cannot because there is no 0 existing in the try. Then for the next node you have 0. This node is 0. This particular element is, this particular bit is 0. So that's why you will want a 1 here. So can I go to 1? Yes, I can go to 1. So I'll write 1 here, right? After that I have this as 1. Can I go to a 0? Yes, I can go to a 0, right? I can go to a 0. Its left is existing, so that means I can go to a 0. So I'll write a 0, and this would, if I XOR these two values, so this would look like 0 1 1. So now the XOR that I'm getting is the binary representation of this XOR. This is bit 1, this is the bit with having power 2, so the overall number would be 3. So I'll say that okay, now if I have the XOR with, if I have 5, so I can get the XOR as like if I choose the number 5, then with this particular try I can get the XOR as 3, right? This is what I can get. Now next step, what would happen if I have the number 2? If I have the number 2, then in that case Aman is saying +1. What about you, Ashish? Is it clear to you? I have the number 1 and 0. I have the number 1 and 0. Now I'll see that whether I can get this first bit as 0 or not. I cannot get because the head does not have a 0, right? It is not attached to any 0 directly. So that's why I'll say that I have to compromise with a 1. I have a 0. Can I get a 1? Yes, I can get a 1. So I'll say, okay, I can get a 1 for this particular bit. So that's why I'll say that, okay, I have this as set. So this would be 1. This is 0. So that means that now this ultimate bit is 1. So that's why my answer won't be like this is max. This XOR is getting 1. So that's why I will not update my answer, right? Next up, I'll have 25. Ashish, it's clear. That's great, right? So up till now the maximum XOR that I have got is 3, right? Up till now the maximum XOR that I have seen is 3. Now let me check for the number 25. Let me check for the number 25, right? Let's check for the number 25. Now I'm checking. Don't worry, I'll teach you the code. I'll be explaining you the code also properly, so you don't need to worry about that, right? So now if I have 25, if I have the number 25, so what was the representation of 25? 25 was 1 1 0 0 and 1. Let me check. So 1 2 4 8 and 16. So this was 16 plus 8 would give me 24. 24 plus 1 gave me 25, right? So this is the representation. What should I do with this 25? So if I have this particular bit, if I'm at this particular bit, so I'll try to choose a 0, but from the head, can I choose a 0? No, I cannot. So I have to compromise with a 1. So I'll say, okay, I'll compromise with a 1, right? Next up, I have a 1. Can I go to a 0 for this bit? Yes, I can go towards the left because left is existing. So I'll say, okay, I can have a 0 for this. Now for this next bit, that is this bit, that is this 0 bit, can I go have a 1? Yes, I can have a 1. If I go towards the right direction, I can have a 1, right? Now the next bit is 0. Can I have a 1? Can I have a 1? No, I cannot have, right? No, I cannot have, right? No, I cannot have a 1, right? That's perfectly visible that I cannot have a 1, right? Because if I have 1, if I had 1, then I had 0, right? Then I had 1, like this, and then like I had 1 0 1, and then in that case I'll go to a 0, right? So in this case you can see this is what I'm getting. Now you will say that, okay, how does that help us? So you will say that it's still not clear, right? Things are not still clear. So I'll say that, okay, this is also not giving you the maximum possible answer, or is it giving you? Let's check this out. So they are saying that the maximum answer that you will be getting is 25 XOR 5, right? 24 XOR 5. So let me tell you how we'll be getting this, right? So if you have a 25, so if you have a 25, so what do you have? You have 1 1 0 0 and 1, like this. Okay, you have a number like this. So you will want that the first bit to be 0, but it's not possible. So you'll write 1, you'll go to this, and you have this 1. Then you will have this as 0 because you can go to this direction. Then you'll have this as 1. Then you'll have this as 0. And since the next bit is not present, so that's why you'll say that, okay, you'll have to compromise with a 0. So what do I get as a bit when I XOR these two values? What do I get, right? What do I get? So I'm getting what? Let me see. So this is 0, this is 1, this is 1, this is 0, this is 1. So this is 1, this is 2, this is 4, this is 8. So 8 4 12, and I'm getting 13. Let's see whether the answer was 13 or not. No, the answer was 28. Okay, so I might have made a little bit of mistake here and there, but basically if you will XOR it, if you will XOR this 25, so ultimately you will get what? You will get 25 if you have a number 25, right? If you have a number, let's say 25, let me write this again for all of you, right? Let's write this again and let's try it out. So if you have 25, so you have what? 1 1 0 0 and 1. So what you will say with this particular number, that you will want the first bit to be 0, right? You will want the first bit to be 0. So you'll say that, okay, maybe I do not like it. You will get it with which number would you get as XOR as 0, right? So the thing is that with which number you will get as XOR as 0, right? So if you have this, so what you can say is, if you don't have a bit, right, so you can mark it as 0, right? You can directly mark it as 0. If you don't if you are having this as 1, so you can also say that let's mark it as 0 as well, right? After that, what you'll say, if you have a 0, so you'll check that whether you have a 1 or not. So you do have a 1, so that's why you'll say 1, then 1 0 1. Basically what you'll get is, once you'll iterate through this particular try, so you'll get 25 XOR 5, and that would give you the optimal answer, that is 28, right? So this would look something like this: 1 1 1 0 and 0, like so. This would be 1 2 4 8, and then you would get what? You would get a number that is 16, right? So this would be 28. So this is how the try would be working. The problem you are comparing with the first bit. Yeah, right. Yeah, that's the issue that I had. Basically you don't rather with the last bit. Yeah, right. You have to compare it with the last bit. You can maybe try to build the try with the last bit as well. That might work as well, but like this approach will also work. Let me show you a little bit of code for that part, like how I am trying to build it and what the other things that I am doing, right? It is not 5 1 0 1 0 0. Yeah, that's perfect. But basically I was trying to build the try like this. Okay, basically I was trying to build the try like this, you can say. Maybe I had some issues by making the try, but basically what I'm saying is, if you have 25, so you have 1 1 0 0 and 1. So in that case what you could do is, you can have a 1 0 1 and you have 0 0, like you will get this particular pair. So in that case you would be able to do it. Let me check the code, maybe if I have done some mistake, but in the code part it's getting accepted, right? So let me tell you how I'll be approaching it. Let me show you the code. So what I would be having is, I would be having a try, right? I would be having a try. So what you will do is, you will try to XOR it in the try with every possible number. So that's how you will try to do it. So you'll have a try, you will try to declare a try first, and then what you will do is, right, you will insert this particular number in the try. Now what does an insert function mean in a try, right? What does an insert function mean in a try? So you will declare a try like this. Okay, so it will be having the root. So what you will be having is, tries current is equal to root, right? So you will iterate for all the 31 numbers. Yeah, right, that's the mistake that I did. Okay, Ayush, Ashish, that is the mistake that I did. Like what I'm saying is, this try, if you let's say you have 101, right? If you have 101, so in the try it would be stored like this. Like, since you are having 32 bits, right? You are having 32 bits, so that's why 5 would be 00101. So that's how you will represent it. Okay, so that is the mistake that you can say that I have done. Basically I just ignore this part, but basically you have to store it like this. Okay, so this try's length would be 32, right? Its deepest length would be 32, because if a bit is 0, then I'll say it's 0, right? If let's say if I have to represent a number like if I have to represent a number like 5, so in that case I would go to 0, then I would go to 0, I'll go to 0, I'll go to 0. How many number of times I would go to 0? If I have 101, right? So that means that 3 bits are there, so 29 times I'll write a 0, and then after that I'll write 1, and then I'll write 0 and 1 like this. Okay, 1 0 and 1. So this is how it would look like actually. So since I did not had much space, so that is why I was telling you like that. But now you must have understood like how you will be relating it with the try. Okay, yeah, this is like Ashish, like I forgot to tell you that since the number of bits are 32, that is why the maximum like that I was considering would be that much, right? Like if you are having, let's say 25, so 25 is represented how? 25 is represented 1 1 0 0 and 1 like this. Okay, so if you have 5, so 5 would be represented how? 0 0 1 0 1. So in that case your try would be like this. If the try is representing 0 5, so it would be having 1 0. Let me draw it again. Sorry for that. Yeah, sorry for a little bit of mistake here and there. Like I forgot to mention initially that that we had to consider this as well, that you have 32 bits, right? So that's how you will be representing it. Let me do this. So this would be 1, this would be 0, and this would be 1, right? Now once my 25 is coming, right? If my 25 is coming, so it's what 1 1 1 0 0 and 1, right? So I'll say that, can I have a 0 for this? Yes, I can have a 0 for this. Can I have a 1 for this? Can I have a 0 for this as well? Yes, I can have a 0 for this as well. Now can I have a 1 for this? I'll say yes, I can have a 1 for this as well. So I'll say okay, I can have a 1. Now I'll say that okay, I need a 1, right? In the try it would be a lot of other structures present as well, but in that case what would happen for this particular 1, now for this particular digit you wouldn't be having a 1, so that's why you have to compromise with the 0. So you'll move to 0, and after that what would happen? You have a 1, right? You do not have a 0 here as well in the end, so that's why you'll have to compromise with a 1 only, and you'll say that okay, I'll compromise with a 1, and then the XOR that you will be getting after that, the value would be 28, right? If this part is clear, so please give me a +1. Everyone, please give me a +1, right? I hope that this much part is clear. Now let me come back to, like, I forgot initially to tell you like that you have to build it for 32 bits, right? So that is why the depth of the try would be 32, right? Initially I was just missed this part, like in the explanation, right? So if a particular bit is set, I'll check if a particular bit is 1, right? If a particular bit is 1, if a particular bit is 1 or 0, I'll check. So what I would be checking is, if a particular bit is there and it is not present, if a particular bit is not present in my try, in that case I will add this new node in my try. Otherwise, if that bit is present, so I'll move to the next, right? What I'm saying, let me explain you, right? So what I'm saying is, if I have 3 can be represented as 1 1, right? 3 can be represented as 1 1, and 5 can be represented as 1 0 1, right? So like if I have a 5, so I have 1 0 and 1. Like let's say if I am at this particular node, and from that particular node if I have already a 1 present, right, and I also want to go to 1, So in that case, I will not be making a new node 1. I'll automatically go to this node 1, right? So that's what I'm saying, right? Right after this, what I would do is, like, I'll build the try for everything, for every data structure and for every number, and the height of the try would be 32, or you can say like from 31 up till 0, right? So I'll be checking for each bit. If a bit is not represented in the try, then in that case I would be representing it, right? Once I'm done with that, so once my try is built, so what would I do? I'll simply check for the maximum answer, right? I'll simply check for the maximum answer in the try. So what I would do for that, so I will mark my answer as 0, and I'll mark my the root, I'll mark my current to the root of the try, right? What I will do is, I'll iterate for each bit. If that particular number is set for that particular bit, so I'll check if that particular bit is there, right? If suppose a bit is 1, if suppose this particular number is having a bit as 1, so then I'll check for not of bit, right? I'll check for 0. If I have a bit as 1, if this number is having a bit as 1, then I want to check that whether there is a bit 0 existing or not. That is why I'm checking for 0, right? I'm checking if there is a bit 0 existing or not in the next path, if there is a bit 0 existing or not. If there is a bit 0 existing, in that case I'll say that okay, my answer would increment by 2 to the power I, right? 2 to the power I, because I is the ith bit, so that's why I'll increment my answer and I'll move to the next node. Otherwise, if the bit 1 is not, if corresponding to the bit 1, if there is not a 0 existing, then I have to compromise with a 1 only. And if I compromise with a 1 only, so that means 1 or 1 would give me 0, so that's why I'll not increment anything to my answer, and I just simply have to compromise with it, and my answer won't get incremented, right? That particular answer or that particular current XOR won't get incremented, right, for that particular index I, right? Is it clear? If this is clear, please write clear in the chat. Like, if I had what I'm saying is, if my current bit was 1, then I'll check for not of bit, right? I'll check not of bit means I'll check for 0. If there is a 0 existing, in my try, if the next node is 0, in that case I will mean that the current bit was 1 and I have a bit 0, so that will mean that my answer would get incremented by 2 to the power I, because that particular bit would become set, because 1 or 0 would become 1, so that is why the answer will get incremented by 2 to the power I. So that is why I'll increment it, and I'll move to that particular node. Otherwise, if that particular bit is not present, so that means that particular bit is not, like the 0 is not present, the opposite bit is not present, right? If my current bit is 1 and its opposite bit is not present for me, right? If the current bit is 1 and its opposite bit is not present, so that means I have a 1 here, right? I have to compromise with the bit 1. So if I have to compromise with this bit, then my answer won't get incremented by anything, so answer would still remain the same. The XOR that I'm making would still remain the same, and my current would just change to the next, right? Is it clear? Please write clear in the chat if this particular part of the question is clear. I'll try to provide you with a much simpler code than this, right? So I just had a little bit of a problem, like because I forgot to tell you that the height would be 32. Initially maybe I should have made it for 32, that should have been better, right? So if the question is clear to all of you, then you can write a +1 in the chat. Now the thing is that you can observe that you have a try, right? And you have n numbers, right? You have n numbers. So for one numbers, like you have a try, right? You have a try, so it will be having some height, or you can say depth. So you will be going at most till the depth, of that particular try, right? So if you are going to that depth of that particular try for each number, for one particular number, right? For just one number, you might go till the height. And height is what? The maximum number, right? Log of the maximum number would be the height. Height here is nothing but log of the maximum number, right? So height is nothing but log of the maximum number. Now if for one number you are going at most, in the worst case you are going for a particular number, you are going till the height of the tree, that is log of maximum number, right? That is the height. So for n numbers you will be going n log of maximum, right? I hope that this part is also clear to everyone. So that is why what would happen? That is why the time complexity would be n log of max, that is n log of the maximum number, right? N log of maximum number, right? And in this case what would happen? Basically it would be very much similar, like this won't be a very big factor, but still if someone is asking you what is the time complexity, so you'll be telling log maximum of x, right? Something like this. If this part is approach is clear, so please write clear in the chat. Shreya, Ashish and others, is this part clear to everyone? I tried to explain it with the simplest way possible. So thanks a lot for joining in. And in case if it is clear, so you can write a yes in the chat and like the video as well. Little bit of mistake that I did initially, for sorry for that. Like I just forgot to tell you that if we'll make zero, so that would take a lot of time. So thanks a lot everyone for watching in, and I'll see you soon in the next live session. So till then, take care, keep